Everybody, today we are continuing with our lessons with the topic partial variation. In our everyday life, we have different situations. But let us consider a situation where a tenant, let's say a worker and a tenant, at the end of the for his accommodation, he pays rent. He pays rent, and it is usually fixed. The owner, or the landlord, or the landlady will tell the tenant how much he or she will pay in the year. So that rent is there. But he equally feels. Let's say he has a family of four, a wife and maybe 3 children, or even including children, maybe 5 or something like that. But we are looking at a situation where the rent is fixed. What he has to pay as rent is fixed. But what he spends on feeding varies as the number of people in the family. Take note. This tenant spends his income partly on rent and partly on the number of people in the family. Look at it again. The rent is constant. The number of people in the family varies. What he spends on feeding depends on the number of people in the family. An example of this nature is an example of a partial variation. What do you say? You say that the tenant's income, or the cost, if we take C to be the cost of running the family, that cost is partly constant for the rent and partly varies as the number of children in the family. So, C you end up saying that C is equal to R, which is constant as the rent, plus Kn. Where C is equal to cost of running home, R is the rent, and N is number of children, or rather, number of persons in family, and K is equal to and R and K are constants. This is an example of a partial variation. The cost of running the family or running the home is partly constant for the rent and partly varies as the number of persons in the family. Then you write something like this: C is equal to R plus Kn, where K and R are constants. Please take note. K and R are constants. A variation like this is an example of partial variation. The cost of running the home is partly constant and partly varies as the number of persons in the family. Such a variation is written in this form. Now let us take a worked example Let us take a what example? What example? R is partly constant and partly varies with E. When R is 530, E is equal to 1600. And when R is 730, E is 360. Find the formula which connects R and E. B. Find R when E is equal to 1300. Look at this situation very well. R is partly constant and partly varies with E. When R is 530, E is 1600. And when R is 730, E is 360. The question says, find the formula which connects R and E. B. Find R when E is 1300. Now, our solution. R is partly constant and partly varies with E. So we are saying that R is equal to a constant plus Ke, where C and K are constants. Where C and K are constants. When R is 530, E is 1600. When R is 530, E is 1600. That is, we are saying that 530 is equal to C plus 1600K. (530) is equal to C and K are constants. And so now we have an equation which leaves us with C and K. It looks like we are going to generate two simultaneous linear equations to enable us find the values of C and K. That is, this is the case when R is that. When, you can call this equation 1. When R is 730, E is equal to 360. That is, we are saying that 730 is equal to C plus 360K. You see that we have got another equation involving C and K. Call it equation 2. It now means that we shall solve equations 1 and 2 as simultaneous linear equations to enable us find the values of C and K. One and two are two simultaneous equations. One and two are two simultaneous equations, and we can solve them. Okay, sorry, there's a 360 there. Okay, there's a mistake in that. There's a mistake somewhere here. This is 3600, please. 3600. This is 3600. Please take note. It's a serious mistake. 3600. When R is 730, E is 3600. And so what happens now? If you look at equations 1 and 2, we proceed now to find the values of C and K from equations 1 and 2. Equation 2 minus equation 1. Equation 2 minus equation 1. Please take note. Equation 2 minus equation 1 means 530 from 730, which gives us what? 200. 200. C, we cancel C. 1,600 taken from 3,600. What do we get? 2,000. K, of course. If you subtract equation 1 from equation 2, you get 200 is equal to 2,000 K. That makes life easy for us. Now, what is K? That is K is equal to 200 over 2,000. And what is it? 200 over 2,000 is 1 over 10. This is the value of K. And we can return to any of the equations to find the value of C. We substitute for K in equation 1. We substitute for K in equation 1. We substitute for K in equation 1. Substitute for K in equation 1. What are we going to get? We shall get 530 is equal to C plus 1600 times 1 over 10. That is now in place of K. And what does that give us? C plus 160. That is 530 is equal to C plus 160. And so what is our C? C is equal to 530 minus 160. What is it equal to? 370. C is equal to 370. And so we can now say that the relationship between the formula which connects R and E is what? Now we have got the value of C, we have got the value of K. So the formula which connects R and C, which connects R and C, is what? R is equal to, our C is what? 370. Our K is 1/10. So it will now be E over 10. E over 10. That is the formula that connects R and E. This is the formula that connects R and E. And we have to find R when E is 1300. We are looking for R when E is 1300. When E is equal to 1300, we have R is equal to 370 plus 1300 over 10, which is equal to 370 plus 130. And what is it equal to? 370 plus 130 is very clearly equal to 500. And so here we conclude this working example. By the special guest of God, in our next meeting, I will take as many work examples as possible. But this concludes our treatment of variation. We have treated direct variation, we have treated inverse variation, we have treated joint variation, and today we are treating partial variation. With this, I thank all of you and wish all of you the very best. May God bless all of you.